Hello everyone. Today let's continue on the fourth episode of Why is DeepSeek cheap and good? The fourth episode is going to be about multi-token prediction. Let's dive into it. First, I want to talk about what is single token prediction or next token prediction. On the right-hand side, this is the classic encoder-decoder transformer architecture. And on the left-hand side, this is an example that I use in my transformer series. So this is doing a machine translation task. It's trying to translate I am Martin to Chinese. In this case, while doing inference, I send the English I am Martin to encoder input. In the first round, decoder input is going to be a start token. And then the output is going to be the translation of a Chinese translation of I, which is 我. And then we take the output and send it to decoder input again, because this is auto regression. And then we get the next token, which is the Chinese for am. And then we get a new sentence, which is 我是, and then send it to decoder input. And then it output the next token again, which is MAR in Martin. We combine everything and send it to decoder input, and at last it outputs TIN in Martin. This is a typical inference for next token prediction. In the next slide, let's take a look at what happens in next token prediction training. So in training, in machine learning, we always relies on minimize loss function and doing back propagation to update weights. So what is the loss function in this case? The loss function we are using is cross entropy loss. So this is a metric we use in machine learning to measure how well a model performs. And it's done by comparing the probability distribution predicted by the model to the actual distribution of the target labels. In math, the formula is loss, and then it's the sum of a probability given x from 1 to t, and then the probability of t plus 1. So in other words, it's given a sequence from x1 to xt. These are all tokens. Let's use example of I am Ruthie's. So these are 3 tokens and forms a incomplete sentence. And the probability of the model predicting next token to be xt plus 1 is this. So it's part of the formula here. So we are trying to maximize this probability. So in training, we already know what xt plus 1 is for each t. And during training, we're going to compare the model output with the actual input, and we're trying to make sure the model behaves as close as the actual output. So in this case, we maximize the probability. And to maximize the probability, it means we're minimizing this loss function, which is what we're actually going to do in training. We're going to minimize this loss function. That's how we make sure the probability is maximized. So this is how the machine learning training works for next token prediction. But is there a more efficient way, like using the same training data? The answer is yes. So let's take a look at the multi-token prediction. This is a paper done by FAIR, which is a research lab from Meta. So they are trying to predict multiple tokens at a time. So the model predicts several future words simultaneously instead of just one. At each position in a sentence, the model uses multiple heads to forecast the next several words all at once. So this working collaboratively to improve the efficiency and coherence. In this graph, they have 4 heads. That means it's trying to predict the next 4 tokens at a time. So the loss formula in this case is going to be, instead of given the token from x1 to xt, instead of predicting xt plus 1, we want to predict xt plus 1 to t plus n. In this graph, n equals to 3. So the advantage of this multi-token prediction is pretty clear. It's more efficient learning. So multi-token prediction enables the model to learn more effectively from the same dataset. It uses the dataset in a more efficient way. And then it also have like better quality in many cases. So this model captures and predict long-term patterns instead of just the next single prediction. So it has better quality in tasks requiring content generation, such as code generation for software engineers. And this is a joke, or not. And then it also has faster inference. I don't see this too much nowadays, actually. Probably it's not used in a lot of model because like extra model complexity or there's actually some quality loss. I want to call this out because DeepSeek is not doing MTP for faster inference. So let's take a look at DeepSeek's variants. So they're trying to do MTP in a little different way, but similar concept. So the differences is they're doing sequential instead of parallel. They do this because they want to maintain the full causal chain. That means your current token only depend on all the previous tokens you have. And doing it parallel is going to break this promise. For example, if we have T1, T2, T3, and it predicts T4 and T5 simultaneously, then T5 is generated without the context of T4. And as I said, they only use to optimize training. As you can see, they have the main model here, and they have the MTP module here. And the MTP module is sharing output head and sharing embedding layers with the main model. So during training, they want to speed up the training convergence. So they are using multi-token prediction, and after the main model is trained and in the inference, they actually dump this MTP module. So they discard the MTP modules. Those are not used in inference. Only the main model is used in inference. So let's take a look at what the MTP module is doing. It basically consisted of multiple components. The first one is a shared embedding layer. So this shared embedding layer is just to turn token into word vectors. So hopefully you're not too unfamiliar with it. If you are, take a look at my transformer series. And then there's a shared output head. This linearly transform of transformer block outputs and then applies softmax to compute the prediction probability. So this is also shared. Then there's the transformer block. It's for attentions. And then there's the linear projection matrix. This is doing linear transformation because we have a concat here. So we want to maintain the rows and columns, the dimensions consistent. And then there's the RMS norm. So this is to stabilize the training process. If you want to learn more about normalization, please refer to my transformer series. This is only used in training, as I said. So the MTP module actually ensures the training process is more efficient. And then once the training is done, only the main model is used for actual inference. Hope this is helpful. Thank you everyone, and if you like my video, please subscribe, comment, and like.